Hi all, welcome back to my channel. I hope everyone is doing fine. I hope everyone is doing great and you guys have completed your respective tasks for the studies or completing right now. I have just ended my day regarding today's, studies. So this is day 113 day of my GATE CS prep. And today I've studied 11 hours regarding algorithms, CN, and digital logics. So mostly algorithm took a lot of time. I think 6 hours mostly because the recurrence relation, the questions are a lot of questions are there, and then I'm making notes. So it took 6 hours out of 11 hours. Rest of the it was divided into digital logics and computer network. So digital logic, I have already completed everything. I think only one or two lecture is remaining. I will complete in a day. So after completing that playlist, you don't have to go to any full course. Like that is very sufficient. Which I followed of 16 lectures from Arpit Yadav. You can also follow if you want to complete because it's as equivalent as any full course, and I find it really good. So DL is also almost done. Only two lectures are left to complete the digital logics. Algorithm is going on. C and I have already completed. C I have completed. I think these are the subject I'm done with. Apart from algorithm is going parallelly. So the new exercise I have started today is solving questions per day. Like fix any time of the day. Like I'll be doing at the once I start my day with like 10. You can pick 5 question per day, but I'm going to do 10 questions per day regarding the topics you have covered, subjects you have covered. You can pick any DPPs, PYQs, or you are comfortable with. Like I'm starting with DPPs because it will little easier before going to PYQs. So let's say I've completed one flow control topic, so you can take 10 questions, spend some time over that, try to solve it. If you're able to solve it, it's good. If not, then you can watch solution, but try. If you have known the topic, you will get some details, write it down. That I'm also doing the same. If I have known the concept and whatever I have know about that question, I'll just write it down even if I'm not completely able to solve the question. So I think question solving is very important at this point of time, not only just completing the syllabus. So that exercise I have started from today only regarding CN. My target is 10 questions per day. So like due to some reasons I could solve only through 3 questions. I think in middle of the day there was power cut, and I've just started with this thing, question solving, and power like went, and then I had to complete the algorithm lectures also because they are already very big. Like I was studying till now, including like it was total of 11 hours today. So that's why I had to stop in between. So but I'll be covering the 7 question plus 10 questions tomorrow, then I'll be starting the rest of the things. So first thing I'm going to do question solving. Like I have whatever the topic I've completed with C and digital logic C, all 10 questions I'll take it and solve it. So that's a new exercise I have introduced because it's very important. And digital logic I've covered like half adder. Let me show you what I've covered in my notes. This is like half adder, full adder, subtractor. Half adder, like it's a combinational device, adds 2-bit number. It's very basic. Then there all the steps, designing truth table, expressions. If it is minimized, then hardware implementation. The half adder, full adder. Then same process for full adder as well. then it came, this is the conclusion. If for half adder and subtractor 5 NAND or NOR gate required, and for full adder or subtractor 9 NAND NOR gates required. This is half subtractor. Then limitation of half subtractor is can't handle the borrow bit from previous result. Then full subtractor, that subtract two 1-bit number from 1-bit number simultaneously. There were no like as such notes to make on this, so that was for digital logic. Coming back to recurrence relation, like my first book is almost completed. Sorry, excuse me for the voice. So this is recurrence relation. You can see the data also I've put in. So there are few methods to solve recurrence relations, like substitution, recursion tree, Master's theorem, change of variable, and we have started with substitution method. So basically you need to expand twice at least to see the pattern. You can also see in definition we found some pattern, and then remove function from RHS. So here like T of n, this is the recurrence relation, okay, not this one. So T of n equal to T of n minus 1 plus 1. We need to expand this T of n minus 1. So for T of n it was T of n minus 1. So similarly for T of n minus 1 it would be T of n minus 1 minus 1, that is T of n minus 2. And this thing plus 1 also would come, and then last plus 1. And same would repeat for still few steps until kth step, and then you can generalize it. You can see this is a generalized formally. And terminating condition, you need to see where it is terminating, like at n equal to 1 it is terminating, so you can find the value of k and substitute the value of k in equation again, so that you will get the relation. Same way here you need to find, like for T of n it's n minus 1, so for n minus 1 it would be n minus 2. You can see, and n minus 2 plus n also would be there. Not plus n, it would be n minus 1, because for n it is n minus 1. Similarly for n it would be n minus 1. You can see here. And then for again T n minus 2 it's expanding to see the pattern, and pattern is like first step n minus 1, second step n minus 2, and so on. So the similarly it would be like at kth step it would be n minus k. Remaining pattern also you can see. Remaining pattern means anyways, okay, you can see here it is remaining pattern. 3 subtracting from n1, 2 subtracting from n, 1 subtracting from n. Terminating condition, T1 used T1 n minus k to get the value of k. Substitute values in above equation. There were some like option, you need to see where it fits and then choose the correct option in it. Similarly, these are the example. You can see you need to find the pattern and then generalize it. Then terminating condition, value of k and mdt, that's how you find the value. All these are examples only, like very, sometimes you are going to get a very long pattern, long equation, and you need to use a concept like logarithmics. Logs are very widely used, but very basics. After log you will see the GB series also, sum of first and natural numbers. These are few things that I've frequently used. You can see here log. I've solved it to see the asymptotically greater value. Here log value again used, and this is the solving you need to see. That was for algorithm. Like, this is 2.5 hours of lectures, but I still left with last 20 minutes, and there are a few 3-4 lectures which are currently going on. So questions also I've solved, and if some concept is there that they teach, I write it down. That also, like framing protocol. So it is very easy once you start solving questions based on that. So I've solved question on framing protocol, bit stuffing protocol, then SR protocol based on that, and what else? I think one question. Total 3 questions only I've solved. First was framing protocol, bit stuffing. Then there was like flag pattern. You need to find it. And in go back n, if some packet lost, how many transmission it would take. We need to count that transmission including the retransmitted one. So that kind of example were there. And throughput, finding throughput in SR protocol. So these 3 example I've done it. I'll do 17 tomorrow. So I'm using JFG DPPs to get this examples for now. So that was my day 113. Let me know how many hours you guys have completed, or how many lectures you have completed today, or what kind of topics, questions you guys have covered. And I would love to know that in comment section. And if you want to be consistent throughout this months till the gate, just subscribe my channel and be with me. And here I'm not going to, okay, I think digital logic, I need to mark it what I have studied. Only that thing is going on. You can see these are, there is no, I think there is no this thing. Okay, there is no bar to mark as completed, so it's fine. Digital logic, no. Thank you all for subscribing and joining my channel. Show the same support throughout. Thank you all.